All right, I'm gonna wait and make sure everybody's put their phone up. So I see some blanks back there. Let's go put our phone up. We've got a quiz today. If I see you with your phone like you kept it, then you will get a 0 on the quiz. So please go put your phone away. It is a quiz day. Most of us can't remember, oh yeah, it's a quiz. I put my phone away, so I'm not gonna get it out, but then we're too compulsive. We've got to check our phone. So just go ahead and put your phone up. You can get it back when you're done with your quiz. You know that you do better when you don't have your phone. Thank you, thank you. A reminder about the bathroom pass, it's on the back wall. If you need to use the restroom, it is fine, but please wait until I am done talking. And make sure you put your name and the time. So this whole practice, the quiz, it's like all factoring. So the first 2 questions, those are nice. You can do fast factoring. Fast factoring is when that leading coefficient, so a coefficient is just a number in front of X. When that leading coefficient is equal to 1, so this first number, when it's equal to 1, you can fast factor. And so when we fast factor, we have to first get a list of factors. So factors are just things that can multiply. So we're going to find factors of the last number. So factors of 12. And I usually just start with 1 and 12, 2 and 6, 3 and 4. Can you think of any others? Yeah, and once we get those, we don't have to rewrite them in the opposite order. We can just stop there. To create or to factor, I will have 2 factors. The reason why I have 2 factors is because this is squared. So I have 2 factors. And the variable is X, so I will have X and X. In fact, I haven't even started the second problem, but I know that it's going to look the same. What I do now is I find factors of the last thing. So I did. Now I want to look for the factor pair. Which pair of these can I put together to make 4? And so when I say put together, it could be add or subtract. I can just put together in some way to make 4. 2 and 6 will work. So I will take those and I put them in the parentheses. It doesn't really matter which order that you put them in. You just put 1 in one, 1 in the other. Now we have to remember what the signs are. And so to figure out what the sign is, I look at the middle number. The middle number is negative. So that means the bigger number has to be negative. That's where I start. From there, if I have -6, would I add or subtract 2 to make -4? If I subtract, I get more negative. Add. That's it. We're going to be doing this over and over and over again. The second question, we have to find factors of 4. So factors of 4, pretty short list. 1 and 4, 2 and 2. Which one of those pairs can I put together to make 3? 1 and 4. So I'm going to put 1 and 4 in my factors. Doesn't really matter which order. You just put 1 and 1, 1 in the other. The middle term is negative, so I make the bigger number negative. If I have -4, would I add or subtract 1 to make -3? Very good. I would add. Your whole quiz is multiple choice. If you struggle with factoring, what can you do? If you have answer choices and they all look like this. Yeah. If you struggle with factoring, if you can multiply, well, it takes longer, but you could just check all the answer choices and see which one works when you multiply. Do you have a question? Okay. So this question, this is one of the not questions. It's a not question. So which of the following is not a factor? Okay. Well, the first thing that I notice on this one, the leading coefficient is not 1, it's a 2. I wonder if they're all divisible by 2. 8 is divisible by 2, and 6 is also divisible by 2. So my first step is going to be GCF. And I will divide everything by 2. On the board, the essential question for y'all, which I'm sure y'all don't ever read it, but it says, why is checking for a GCF so important? Well, number 1, it can help you find the right answer, but 2, it can make the answer or the question easier. So we don't know how to factor when the leading coefficient isn't 1. So factoring out this 2 will be very helpful. So when you factor out a 2, it doesn't disappear. It gets rewritten out into the front. And then we write down what we have left. So if we do 2 divided by 2, we just get x squared. 8 divided by 2, that's going to be 4. And 6 divided by 2, that's going to be 3. Well, we're not done because now what's inside, that looks a lot like question 1 and 2. So I'm going to factor it. I know that I'm going to end up, the 2 doesn't go away. It has to stay in front. I'm going to end up with some factors, and they're both going to have an x. And I'm looking for factors of 3. So factors of 3, pretty short list. I've got 1 and 3. I go put those in the factors. 1 and 3, doesn't really matter which order. My middle term is negative. So the bigger number is 3, has to be negative. If I have -3, would I add or subtract to make -4? Subtract. So now I can go through and I can look at my answer choices. It says which one of those is not a factor. So we need to go through the answer choices and figure out which one is. So is 2 a factor? These are my factors. Yeah. Is 2 a factor? Yeah. Is x plus 1 a factor? No. What about x minus 3? Yes. What about x minus 1? So the one that is not is the second one. Question number 4 is distribute. I believe that you guys should be able to distribute. I'm going to distribute up on the board. I want you to try and do it on your paper. So Miles, if you want to put your phone on the wall, we are getting ready for our quiz. Did you get the same thing when you distributed? Remember, when you distribute, you multiply the numbers and you add the exponents. So 2 times 3 is 6. 2 and 1 makes x to the third. 2 times negative is -2. X and X makes X squared. 2 times 5 makes 10, and it has just one X. Mhm. Okay. Mhm. Moving on to question number 5. It says, which of the following is equivalent? Because I forgot to change that question. We're just going to factor. So anytime that leading coefficient is not 1, we're going to check for a GCF. This is a 2, so we're going to see, does everything divide by 2? Yep. Same thing over here. The leading coefficient is not 1. It's everything divided by 4? Yep. So both of these, we've got to divide first. So this one we will divide by 2, divide by 2, divide by 2. The 2 does not disappear. It gets rewritten out in front. 2 divided by 2 is 1, so I have X squared. That makes me happy. 24 divided by 2 is 12. What's 72 divided by 2? 36. So now we can fast factor the stuff that's in the inside. We're going to take that 36 off to the side. We need factors of 36. 1 and 36. 2 and what makes 36? 18. Got 3 and 12. And then 6 and 6. All right. So setting everything up, I got 2 factors, 2 more factors. They both have an X. Which factor pair could I put together to make 12? So the middle term is negative, so the bigger number has to be negative. Which one is the bigger number? They're both the same number. That means they are both negative. There is another way to write something when it's exactly the same. So that is the same thing as, you can write it one time. That's what that means. That factor is twice. That's how you would see it in an answer choice, by the way. So this exponent means that factor is twice. So if you're checking an answer choice, you have to make sure that you take this, and if you see that it's squared, you have to write it twice and you have to use a box. For question number 6, we're going to have to factor out that GCF. So all of these are divisible by 4, so we're going to divide everything by 4. I know that when I do that, just the fact that I am dividing by 4 means that answer choice D works. I can already check it off. It works. Out in the front goes a 4, and then I write down what I have left. 4 divided by 4 is 1, so I get X squared. 12 divided by 4 is 3. 16 divided by 4 is 4. I have to find factors of 4, things that can multiply to give me 4. So 1 and 4, 2 and 2. When I get my factors ready, I've got 2 sets of parentheses and they both have an X. Which factor pair can I put together to make 3? 1 and 4. When I put it together, I look and I see that my middle term is negative. So my bigger number, which is a 4, has to be negative. If I have negative 4, would I add or subtract 1 to make negative 3? Add, because I'm getting less negative. So I already see that 4 is a factor, X plus 1 is a factor, and X minus 4 is a factor. The question is saying which one is not a factor. So the one that does not work is X plus 4. Okay, down at the bottom, which of the following is equivalent to this? Okay, well, these are not all divisible by 6, so I can't just factor it. What I'm going to do is I'm going to box my answers. So I'm going to start doing it. I want you guys to do it on your paper, and I want you to see if you guys can figure out which one is the answer. You can use a box. It seems tedious, but that is a surefire way that we can solve this problem. So I want you to start boxing on your paper and see which one is the answer. Did you guys figure out an answer yet, or are you still multiplying? What do you think the answer is? Okay, Ty has a vote for A. Let's check and see if he's right. Okay, next we'll check D. Oh, I got a vote for C too. Okay, well, we are struggling. Okay, so I'm gonna box, well, actually, I'm gonna foil because I have more room to foil. If you box, you're gonna get the same answers, but they're just on the inside of the box. 3 times 2 is 6, then we got x squared. 3 times 4, so plus 12x minus 4x. And then negative 2 times 4, so minus 8. The middle terms we'll put together. So we get 6x squared and minus 8. So far it's good. 12 minus 4 is 8x. A works. Good job. On to the back. So these were kind of tricky because we've never really done find the solution. So I'm going to show you 2 different ways that you could find the solution. One way is that the solution means that when you plug in these as x values, so it's saying that those answers are x equals. And if you plug them in, what you get, that will equal 0. If it equals 0, then it's a solution. If it doesn't equal 0, then it's not a solution. So one way you can see if it works, I'm going to plug in 2. So that would be not that. 2 squared minus 6 times 2 minus 16. The simple function calculators suck at evaluating stuff like this, so you got to just be careful. What is 2 times 2? 4. And then we've got minus, what's 6 times 2? 12. And then minus 16. Okay, gonna go at it again. So what's 4 minus 12? Negative 8. Minus 16, I'm getting even more negative. I know it's going to be a negative number. Is that equal to 0? No, so I don't even have to finish. It's not equal to 0. So the next one, I'm going to plug in an 8. So 8 times 8 is 64. Minus, what's 6 times 8?
48.
All right, we've got 64 minus 48. What is that? What? 64 minus 48. Type it in if you're not sure. 64 minus 28.
It's 16 exact.
Anybody else get 16? Okay, what's 16 minus 16? It equals 0. That means this one works. I don't need to check the others because I just found an answer. So you can plug in the answer choices and you can see which one gives you 0 as a value once you evaluate it. The other way you can do it is you can factor it. So like this second one, I mean, they're similar. You could factor either one of them. If I factor this one, I'm looking for factors of 12. So 1 and 12, 2 and 6, 3 and 4. And I'm looking for the factor pair that when I put it together, I could get 1. So which one of these factor pairs could I put together to get 1? Three and 4 would work. So I can take 3 and 4 and put them in here. My middle number is positive this time. It hadn't been positive, I feel like, this whole practice. So the bigger number, which is 4, needs to be positive. If I have 4, would I add or subtract 3 to get just 1? I'd have to subtract. So these are my factors. And if you factor to find solutions, solutions always mean equal to 0. So solution means equal to 0. So you have to set each one of these equal to 0. So you get x minus 3 equals 0. X plus 4 equals 0. Well, what minus 3 gives you 0? 3. So 3 is a solution. What plus 4 gives you 0? One way you can think about it is if you look at what's in the factors, look how it's minus 3, but the solution is plus 3. Here it's plus 4, the solution is minus 4. So they're always opposite. The solution is opposite of what's in the parentheses. So if we look through the answer choices, not 12, not positive 4, yes for negative 4, actually yes for 3 as well. I hope that on the quiz I made it to where there was only one answer, but looks like I didn't here. If that was the case, just circle them both. My goal was to have just one answer on the quiz, but I was making this practice at like midnight, so things happen.
Why were you making it at midnight? Were you tired?
Yeah, I was very tired actually. Well, because I mismanaged my time, Logan, and I got home and my husband was watching Survivor and I got stuck watching Survivor too because it was intense. So that's why. And everybody else got to go to sleep and I still had to stay up and do homework. So question number 10, it says if y is equal to 2x squared minus 4x minus 5, what's the value of y when x is equal to 7? Well, if they're telling you that x is equal to 7, that means they want you to plug it in. So it's saying x is equal to 7, so I'm going to plug it in where I see x. So now I'm going to evaluate slowly because I'm squaring something. So what's 7 times 7? What? 49. And what's 4 times 7? 28. So now I can do 2 times 49. What is that? Okay, what's 98 minus 28? And what's 70 minus 5? On Survivor last night, one of the things they had to do as their challenge was they had to go look at, there was all these numbers with spaces, and then they had to go look at this rotating wheel, and on the wheel had operations. So they had to memorize the operations to go plug into the equation. And then they had to solve the equation. And I was like, things that you could learn in college prep math. How to evaluate a string of numbers. Okay, that's how we do it. We plug in whatever the X value is and we get a number. We only got two more. These are things we did last class. So these are both perfect squares. Remember that perfect squares are numbers like 1 times 1 is 1, 2 times 2 is 4, 9, 16, 25, blah, blah, blah. These are numbers that you multiply by itself, and these make perfect squares. So we want to look and rewrite perfect squares as something squared. But for this one, 2 is not a perfect square, neither is 18. Because, like it says on the board, you gotta factor out the GCF. There is a GCF. They're both divisible by 2. So you factor out that 2 and you put it in front. 2 divided by 2 is 1. 9. That is definitely a perfect square. It's right here. It's the same thing as 3 squared. So 9, what if I rewrote that as 3 squared? Then I can use that formula. So remember that formula is you've got 2 parentheses. One's going to be plus, one's going to be minus. You put the first thing first. So what I see first is an X. So X goes first. What I see second is a 3. You only use the values, you don't use the square part. So then the 3 goes second. And that is factoring. Perfect squares. And the next one. Oh, that's weird. It's actually not squared, it's the 4th. And I heard you, Logan, you are correct. 81, we could definitely rewrite that one. It's the same thing as 9 squared. But X to the 4th, that actually rewrites, you might not have thought about it, but it's the same thing as X squared. That's weird, but it's true. So I'm actually going to rewrite this one to make it a little cleaner. So we've got X squared minus 9 squared. As soon as you have something squared minus something squared, then you can do that perfect squares pattern where you've got a plus and a minus. Doesn't matter which one's plus or minus. Doesn't matter. One's going to be plus, one's going to be minus. And then you put first things first. So I see X squared is first. So X squared and X squared. And then I write what's second. The thing that's second is just the 9. Except for, looky. We just solved this. What is X squared minus 9? Well, it's equal to plus and minus 3. That right there can factor one more time. It's actually a perfect square inside a perfect square. So this one can factor again because it's another set of perfect squares. X squared plus 9 is not a difference, so that one doesn't work. But we just figured out that X squared minus 9, it is this. So we get X plus 3, X minus 3. It's not a difference. So it's not a difference of perfect squares. This only works when you're subtracting difference. That's the only one that it works with. You're going to make sure you got your name on it and you're going to turn it in.